So, hello everyone. I am Lionel Sanchez, and I will be talking about plastics and synthetics in industrial design. So, in this session, we are not just learning what plastics are, but we are also learning how the designers choose materials, and more importantly, what they choose to ignore when they do. Plastics are everywhere, and in your lives, in your phones, in the chairs that we sit on, in the packaging that we use, and even in medical devices. So the question is not what plastic is, but why this plastic is here and why this plastic is now. Plastics are very powerful because they sit at the intersection of form, cost, speed, and accessibility. So, a designer who understands plastics can control the scale by which you apply your plastics onto your products in industrial design. So, a designer who misunderstands plastics also um, can create wastes and failure or harm in the environment. So, how do you read a material key property to consider when it comes to choosing plastic? So I'd like you to think as of the material as systems and not just the material as it is, but material also not as just a data set or some numbers. So every property affects the form, the manufacturing, the lifespan, and the disposal of your product that you are designing. So good industrial designers do not just memorize these properties, but they interpret them. So, for example, the strength of a plastic, the thermal behavior, so how it responds to heat, including the melting points, the environmental costs of choosing such a plastic for your product, the flexibility or the ability to deform, elasticity even without breaking the plastic, and the density of the plastic, which is what defines the weight and the portability of the plastic that you would choose in your design. So let's talk about ABS first. So ABS is the material of controlled toughness. ABS does not shatter easily, and it is a plastic that tends to absorb shock. So that's why it lives in the dashboards, in electronics, and places where failure would be visible and dangerous. But ABS also tells us something uncomfortable. And what is it? It is that its durability often comes at a certain environmental cost. And yes, it is strong, it is moderately flexible, but again, it is petroleum based, and so therefore it has some repercussions when specifying this kind of plastic for your product. ABS also lets you design with confidence, yet again, with an environmental cost. But it also locks you into a dependency on petroleum, and it has limited recyclability. So the question when choosing and specifying ABS is durability enough to justify the permanence of the product that you are designing. And next is polypropylene. Polypropylene is a designer's ally when motion seems to be something that you might want to consider in design. It is highly flexible, it is resistant to fatigue, and it is very lightweight. This is very much suitable for hinges, for snap fits, for reusable containers. PP also bends without breaking, and it is very efficient and often invisible in the daily life. So it means like we sometimes like take its properties for granted. Polypropylene is recyclable though, but the recycling is very much a system and it's not really a promise. And yes, it is highly recyclable, but it is non biodegradable, and it has risk to the pollution in the ocean. So the material outlives its product logic, and then sustainability is not about. Remember, the sustainability is not about the material choice alone. It's also about the intent of the product that you are designing. Okay, so PVC or polyvinyl chloride, it is a controversial plastic. One of its key properties is that it is strong and it is rigid. It is very flexible and is high density, so it is compact. And it can be found almost everywhere. And that's exactly the problem that we have with PVC because it is cheap, it is durable, and it is very much adaptable and flexible. But it also carries one of the heaviest environmental and health footprints rather among all the plastics. So yes, it can be very harmful to the environment. So PVC forces designers to confront ethical concerns when trying to specify them because it is very difficult to recycle. Just because a material works does not mean that it should always or be necessarily be used. Industrial design is also not neutral when it comes to PVC. It can be very political with in terms of government regulations. Of course, it could be the choice could be a matter of being an environmental one and also a moral one. Okay, so let's go to epoxy. It is the material of permanence. One of the key properties of epoxy is that it is very strong. It is rigid after cutting the epoxy, and is very resistant to heat and chemicals. So once epoxy is cured, it can no longer be undone. So that is what we should be considering when using epoxy, and that is what makes epoxy very powerful. And at the same time, because it cannot be undone, it is also a dangerous material in terms of sustainability. Epoxy also reminds us that some design decisions are what you may want to call irreversible. When you want to specify epoxy, use it when performance of the product that you are designing is very critical, but acknowledge also its end of life costs. Please do remember that responsible design begins with your foresight as a designer. So again, because it is non-recyclable, that is the trademark, or rather the trade-off of this certain plastic. Okay, so let's go on to rubber. One of the key properties of rubber that it is very much elastic, and it absorbs energy, high energy absorption, and rubber also in rubber we also want because there is a natural and synthetic rubber, so you have the choice because rubber again it is very absorbent to the energy. It's sort of cushions act like a cushion, and natural rubber gives us a glimpse somehow of biodegradability of plastic. But at the same time, when you use and specify the synthetic kind, it reminds us of dependence of this industry. So, rubber is used heavily, in tires, in clothing, in flooring, even in rubber gloves, in rubber adhesives, in certain ducting, even in erasers, in rubber swimming tubes, rubber sheet products, and so much more application. And as I mentioned earlier, it absorbs energy, so it is also used as an anti-vibration isolation pad. Rubber rarely returns to its original form, so most recycling is actually downcycling. So designers must ask: Is elasticity a worth performance of the product that you are designing? So rubber, it has really a limited recycling um, capability rather. So you tend to downcycle it because recovered rubber is shredded into a much more lower value fillers, no, like for playgrounds, rather than it returning to its a new product. And the pollution risk that comes with rubber is microplastic shedding from the wear, particularly the ones used in the tires, and it also creates persistent environmental contamination in the waterways. So, if you will compare these different types of plastic, perhaps we can say that no plastic is ever perfect because design is the art of choosing which you will compromise and which you are willing to live with. So there is this ongoing tension when choosing and specifying plastic. Do we want strength, or do we want the material to be flexible? Do we want it to be heat resistant, or do we want it to be recyclable? And do we choose its plastic over its performance, or do we really want to be ethical in the choice of plastic for the product that we are designing? And so, as industrial designers, we could most probably reflect that uh, you are not just making and shaping objects, but you are shaping systems, you know? um, because when you use plastic, you also consider not just its use, but the waste that you are generating when you use this type of plastic. Of course, the labor also, and the environment, its environmental impact. So plastic, remember, are just tools, no? And your judgment actually is the real material. So choosing between those tensions that I mentioned a while ago, And important to remember also that good design solves problems, and responsible design anticipates consequences. So that's something to keep in mind in this particular module. So thank you for listening, and I hope you will have a great day ahead. Goodbye.